I gave a plenary talk at the National Academy of Engineering annual meeting in October on the topic was AI and engineering education. So a number of the things that I'll show you here actually are borrowed by that. And I just wanted to preface everything by saying that when I first started as a professor, my department chair told me that engineering is about three things: energy, materials, and information. My thesis was on energy, so I said, fantastic, I am in this very specific area here. Well, AI is actually a combination of all these three at an extraordinary amount. It's about energy. We all know how much energy it consumes. It's about materials, chips of NVIDIA. You see all the stock price, how much it is going to be. And it's, of course, about data and information. So when I look at this, it's almost like a manifestation of engineering that we've never seen before, but in a different way. And so I think that's something that permeates a lot of the things that we do. But there is an additional aspect to it, which is the concept of trustworthiness, because understanding and the interpretability that we mentioned before is a very important part of understanding the whole aspect of AI. And this is what comes in from the human element. So to me, now AI and engineering consists of all these three things plus trustworthiness, and I'll say a few things about that in a moment. So I'm pushing something. Oh, okay, yeah. When I was thinking about what's going on in the world today, I'm asking the question, what is going to remain constant in the future? So it's an important question to ask. And I believe that what will remain constant in the future is addressing four big problems that come up in four buckets. And I believe this is true for any discipline, not simply engineering. And the four buckets are, one is what I call sustainable prosperity. I don't call it sustainability for a number of reasons. Sustainability sometimes has has taken a political view that makes it actually be a little bit alluding to scarcity. And I think we need to get out of that. When I was in the Greek word for sustainability, I'm sorry, you have to tolerate me on this, is aiphoria, and aiphoria means forever green. And so when you don't talk about sustainability in the sense of viosimotis, which is the viability, but you talk about aiphoria, which is forever green. I believe if we start thinking about sustainability in this way, we actually are going to go much further than before in terms of making this something important. Another big bucket is health, obviously. A third big bucket is security. Security, whether it is cybersecurity or space or other things as well. And the fourth bucket is enriching life, which I think is something that is obviously something that we care about a lot in many disciplines as well. And so enriching life, whether it's education, scientific discovery, entertainment, all the other things, democracy, whatever you want to call it in terms of. So to me, this is a more engineering sort of a chauvinistic view of things, but I believe that a lot of the things that we do are fall in these buckets. So I have been trying to put all this together, and I created some sort of a Maslow hierarchy for humanity, which is this triangle over there. By the way, people call it pyramid, but you all know that it's not a pyramid, it's a triangle. Just want to make sure that everybody understands that. Also, fundraisers talk about the pyramid of fundraisers. Actually, it's a log-log plot of a power law, but that's a different story. So I think that this will remain constant for the future, for many, many years, because we really like to have all these aspects in our world today and in the future. And so the question that, so it is very important for our students, for example, let's say engineering students, that we demand from them a deep technical domain knowledge in these areas. In other words, we cannot simply say that all of this will be done by AI. We have to make sure our students understand that and they're masters of this. So this is something that when we look at the future of education, it is very important that we have that principle. By the way, this is back in 2008, the National Academy of Engineering articulated what's known as grand challenges of engineering, and essentially are these buckets that I mentioned here as well. This is my Maslow hierarchy, okay? Just want to make sure. Then the question is, what accelerates? Clearly, what accelerates is AI and computing ability in some sense. Transformational moment, it's more than an exponential nature, as we know. It actually approaches a singularity, most likely, and possibly a phase transition. So I have a very simple, I'm not an innovation guru, and I'm not a business person. However, it's very interesting to see that if you look at the kinetics of innovation in a very simple way and make the kinetics of innovation that are autocatalytic, so you have, let's say, the ADT is proportional to A, then you get an exponential. So I discovered for you Moore's law, just one equation there. However, if you make this to be a second order reaction, let's say proportional to A squared, the kinetics, then you get a singularity, which is actually something interesting. That, in other words, if this acceleration is faster, then you're going to get a singularity. Singularity gives power laws. Power laws are essentially associated with phase transitions from physics. You probably know that as you approach the singular point or the transition point. So so I believe that we are. It's not my own discovery of this, but it seems to me that we're phase transition to autonomy. And when I look at AI, I look in terms of three things: AI as a tool, AI as a catalyst, it's not shown here, and AI as a technology. And I will explain to you in a moment what I mean by all these three things. For our students, demands to have deep technical knowledge of AI. What does it mean? Machine learning, all the things, neural networks. So a commitment that we're making to our entering undergraduates at USC is that by graduation, they have a working knowledge of AI, understanding the mechanics of AI, whether you are in CS, electrical engineering, chemical, or anything like that. It is very fundamental for our students to understand that and to demystify, to some extent, if we can, what AI is. So this is the thing I wanted to mention. So I will now give you, and I hope you forgive me, a symbolic equation of whatever I just said before. And please do not throw tomatoes at me, but this is my equation here. So I am asking you to take a triangle with the Maslow hierarchy, then add to it the hyperbole, which is the singularity, and then you're going to get a double helix. And the double helix consists of two strands. One strand is technology, and the other strand is humanity. It's the two fingers that you showed in your thing before. I look at it in a different way. And as I said, this is something that I believe we live in this world today in a very significant way, and that's why you have to have sort of the human in the loop, which is actually this intersection between technology and humanity, which I think is reflected here. So my hope is that we will continue trying to solve important problems, whether it is on sustainability or sustainable prosperity, as I call it, health, which obviously is going very fast, security, and all these other things, with a significantly advanced computing to be able to create this intersection that will require a very fine tuning, if you wish, between our interaction between technology and humanity. Before I go there, I wanted to mention a little bit. I mentioned AI as a tool, as a catalyst. I'm a chemical engineer, so I have to use a catalyst thing, and then as a technology. The tool is obvious. You just Google something. It's like Googling something. That's fine. In terms of catalyst, I think it has tremendous implications with respect to the acceleration of science, which actually we see today, but also acceleration of learning or how we do learning. And all these are going to change dramatically in many different ways. So, by the way, thinking about learning, and I'm not a learning expert, but it requires, in some sense, a change of your the connections in your neural in your brain. That requires energy. That requires, most likely, this is an endothermic reaction. In other words, you have to be able to spend energy in order to get from one place to another. I think AI is a catalyst that can help there, but the question is to make sure that this energy that you have to put continues being there in order to be able to get this transformation, if you think about it. Clearly, with respect to acceleration of science, this is happening in front of our eyes. And I think the important question that comes of discovery, the important question that comes in is, what is the role of PhD students in the future? Are we going to demand our PhD students 5 years that we do now, or will it be 2 years? I mean, with the acceleration, how are we going to judge the achievement of our students and or the development of talent? And I wanted to mention a little bit about AI as a technology, and that I think addresses the issue why AI is cutting across all disciplines. I use a definition for technology based on a Brian Arthur definition in the 2008 period of time, in which was the following: technology is leveraging phenomena for useful purposes. So that's my definition of technology. I don't say anything about this other than saying what the phenomena are. So it could be physical, chemical, biological, and increasingly social and behavioral, if you think about it. So before AI, we use this phenomenon. Actually, we use it even now when we do, physics-informed machine learning or chemistry-informed machine learning and all these other things as well. However, when we talk about AI, we don't leverage phenomena for useful purposes. We leverage data for useful purposes. In other words, we have removed physics, chemistry, everything out of it. All of a sudden, all these techniques become very similar to each other. So I think this is this convergence that you see in the place as well. And that is the end of my presentation.